Pedometers are used to track the number of steps taken by the person wearing them. There is good reason to believe that the number of steps taken by individuals each day follows a bell-shaped distribution. Maria used her pedometer on a random selection of 16 weekdays. The average number of steps recorded by her pedometer was 4,801.1. The standard deviation for the number of steps was 702.3. Use the data collected by Maria to construct a 95% confidence interval for the true mean number of steps walked by Maria each weekday. Maria used to believe that she walked at least 5,000 steps per weekday. Does the interval contradict her past belief? Okay, so they're asking us to construct a confidence interval, right? So that seems clear, and it's for the true mean number of steps walked each day by Maria. So let's start with our first step, which is to kind of copy down all the data from the problem. We should always have a sample size, a sample mean for these problems, some kind of a standard deviation, a confidence level, and an alpha. So what's the sample size? Well, it says that she recorded her steps for 16 weekdays, right? The sample mean was 4,801, so 4,801.1, and the standard deviation was 702.3. The confidence level in the problem is 95%, and then the alpha is 0.05. Okay, so that's our data step. Our next step should be to come up with a critical value, right? And here I'm going to say that we need a critical t value. Why critical t? Well, the reason why it's a critical t value is because I always want to glance over here and say, what's the sample size? That's less than 30. So I'm going to then say that I need to use a t alpha divided by 2 value with a corresponding degrees of freedom. All right, so what is the alpha divided by 2? Well, half of this alpha is t.025. The degrees of freedom here would just be n minus 1. So since n is 16, we're going to go ahead and say the degrees of freedom is 15. So we'll go to our t-chart, look in the 0.025 column under 15 degrees of freedom. So here we are in the 0.025 column. Go down to where it says 15 degrees of freedom. And sure enough, we get 2.131, right? So we're in the degrees of freedom column where it says 15, and we get 2.131. So 2.131. Okay, so you have your critical t value. Let's go ahead and do the margin of error. So the margin of error is very similar to what we used before. The formula basically will say E is equal to T alpha divided by 2, S divided by the square root of n. So E is equal to 2.131 times S, which is 702.3 divided by the square root of 16. Okay, so let's work that out. So it's just 2.131 times 702.3, and then we just divide that by the square root of 16. Since we know that's 4, let's just type 4. So we get 374.150, etc. Let's take that margin of error. We'll store it in our calculator. I'll just store that as x, for example. Now it's in my calculator, and we'll use it in the last and final step, the step that involves constructing the actual interval. Okay, so the final step is the same as before. It's x bar minus e and x bar plus e. Okay, so in our case, it'll be 4,801.1 minus the error, which is 374.150 approximately, right? And then 4,801.1 plus that 374.150. All right, let's work that out and see what that gives us. So 4801.1 minus the error, and then the same thing plus the error. So you get 4,426.9, 4,426.95 to 2 decimal places, up to 5,175.25. Okay, and remember, this is where we think the true population mean is, right? So this is where we think her true mean value lies. It's somewhere between these two numbers. Okay, let's see now if we can answer the follow-up question they asked us, the interpretation question. So they say, hey, Maria used to believe that she walked at least 5,000 steps per weekday. Does the interval contradict her past belief? So she used to think she walked 5,000 steps or more per weekday. Does this interval contradict that statement? I'm going to say it doesn't contradict that statement, that it does not contradict it. Why? Because she's basically claiming that her mean number of steps is greater than or equal to 5,000 steps each day. So 5,000 steps, where does that lie with regard to our interval? I'd say it's safely inside the interval, right? It's one of the possible values. So it's very possible then that that could be the population mean, or it could be something higher than 5,000 even, right? This interval upper limit goes up to 5,175 steps approximately. So I think then it's reasonable to say that the interval does not contradict her claim. Of course, it also doesn't say her claim is correct, right? I mean, after all, the sample mean was only 4,800 steps roughly, right? So the average for the 16 days she tracked wasn't 5,000 or greater, but remember, there's going to be some random error there, right? Some fluctuation that occurs, and that doesn't mean that the true population average for the number of steps she takes is less than 5,000, right? So the fact of the matter is that the interval includes 5,000, and so why that's important is you're saying, hey, then it's possible that she's right. It's possible that the true population mean is 5,000 because it's one of the candidate values between the two interval limits, right? So we're saying, hey, maybe the mean is 5,000. It's possible at least. The interval, it can't be used as evidence to contradict her claim, right? It's not definitive. So basically at this point, it's sort of an open question, right? Yeah, maybe it is 5,000, right? But we can't say that it isn't, not based on this interval. However, what if the interval had been, from something like 3,500 steps to 4,000 steps? I think we'd then be able to definitively say, hey, doesn't look like she's walking 5,000 steps or more per day on average, right? So it really depends what the interval turned out to be, but the criteria in this particular case is that, does the interval contain the number she mentioned, right? She thinks the mean is 5,000 or greater, and 5,000 is part of the interval, so maybe it is 5,000. In other words, the interval can't be used to contradict her statement. It's also possible that it's something less than 5,000. The interval includes values that are less than 5,000, so it isn't a definitive victory for her, right? However, what if the interval said that it ranged from 5,200 steps to, 5,800 steps? Then every value that we would say is a candidate for the population mean with, 95% confidence would then be higher than 5,000. And then you could say, well, yeah, maybe she's right? Because the interval here supports what she's saying. She's saying the average is 5,000 or more, and all the numbers in this interval are 5,000 or more or greater than 5,000. And in that case, we'd be able to say, hey, maybe she's right. And the interval supports her. Here, though, we can just say what? The interval does not contradict her statement, right? She says it's greater than or equal to 5,000. And indeed, there are some numbers in the interval that are greater than or equal to 5,000. So it's possible she's right. Of course, it doesn't mean that she is right? It just says that this can't be used as proof that she's wrong.